Moving right along to page 3 of your chapter 11 study guide tutorial video. These next set of questions is all about solving. So what I'll need you to remember is that in these solving equations, it's just like algebra, right? We're trying to get x by itself. But if your variable is in an exponent, so if variable, I like to say, is stuck in an exponent, we want to isolate that exponential term first. If a variable is stuck in an exponent, we want to isolate that exponential term first. Once that happens, then take the log or the natural log of both sides. And that's what gets it down, so to speak. Okay, so for instance, for number 30, my exponent, it has my variable, which is x, it's 9x. So that I'm going to say that that exponential term is e to the 9x power. I want to isolate that term first. So I'm just going to use regular inverse operations to get that term by itself. At 8e to the 9x power equals 51. Divide both sides by 8, and I'm left with e to the 9x power is equal to 6.375. So I've successfully isolated my exponential term. Then it says take the log or natural log of both sides. It does not matter which one you take. However, I recommend whenever you have e that you take the natural log of both sides, because we know that the natural log of e is equal to 1, just like we know that the log of 10 is equal to 1. So anytime you have e, it's good to take natural log. So if you take the natural log of both sides, when we do that, our exponential term then drops out in front. That's the whole point of taking the net log or natural log of both sides. So then that 9x comes out in front, times the natural log of e remains, equals, on the right hand side, I've just got the natural log of 6.375. So as I mentioned a second ago, the natural log of e is equal to 1. So anytime that comes up in your equations, you can simply omit it. Because if that's equal to 1, anything times 1 is just itself. So then that leaves me literally with just 9x equals the natural log of 6.375. And then if I want to get x by itself, I can divide both sides by 9. And when you do that, the directions say round to the nearest thousandth, by the way. So then you should get x is equal to 0.2058. For any of these questions, remember this is the graphing calculator section, so if you wanted to check your answers, literally go substitute this value in for x in your original equation. Just make sure you get a true statement. Number 31, my exponential term is 13 to the 8 minus 8x power. So if I want to isolate that, I'm going to divide both sides by negative 10, so that I get 13 to the 8 minus 8x is equal to positive 2.5. Once it's isolated, you take the log or the natural log of both sides. Now, I don't have e here, so if I don't have e, typically I'd take log. Again, you could take the natural log, it doesn't matter. But just because you don't have e, it just means you won't be able to cancel anything. When you take the log or the natural log, that exponent now drops out in front, and it stays together, so you got to make sure to keep 8 minus 8x in parentheses. Times the log of 13 is equal to the log of 2.5. And then remember what your goal is, guys. Your goal is to get x by itself. So if you wanted, you could distribute this log of 13 to both of these terms. To me, there's really no point to it. I would just, at this point, go ahead and divide both sides by the log of 13. So then when we do that, we end up with 8 minus 8x is equal to log of 2.5 divided by the log of 13. That's going to be 0.3572 approximately. Again, leave that decimal in your calculator and just keep working off of that same decimal. So again, if I'm trying to isolate x, I'm going to subtract this 8 from both sides, leaving me with negative 8x equals, that's going to be negative 7.6428. And then we'll go ahead and again keep that decimal on your calculator and just hit divided by negative 8. And then you'll get that x is approximately 0.9553. Number 32, I've got 3 to the 2x minus 2 power. And then on the right hand side, I've got 2 to the x power. So this is a scenario where both of my exponential terms are isolated. There's not a bunch of other stuff. But the thing to keep in mind is that I do have 2 of them, okay? So again, I don't have e, so if I don't have e, I'll just go ahead and take the log of both sides. And when I do so, these exponents will come out in front, giving me 2x minus 2, again, it needs to stay attached, so keep that in parentheses, times the log of 3 is greater than x times the log of 2. Now, the difference between this one and the ones we've done so far is that there are x's on both sides of the inequality. So this is at a point where it would make sense to go ahead and distribute this log of 3 into both of those terms. So that would be 2x times the log of 3 minus 2 times the log of 3 is greater than x times the log of 2. And then we want to group all of our terms that have an x in it on one side of the inequality. So on the left side, I'm going to go ahead and subtract 2x minus the log of 3. And these are not like terms, so I'm not, I'm not like combining these. I'm just literally moving it. So it's going to be rewritten as negative 2 times the log of 3 is greater than x times the log of 2 minus 2x times the log of 3. And then the reason for doing that is because my left side can stay the same. Negative 2 log of 3 is greater than. Then I can factor out an x from both of these terms and get the log of 2 minus 2 times the log of 3. And then in order to isolate x, that's the only x term that I have. It's being multiplied by all this other stuff. So then I can go ahead and just divide by all of this stuff. Log of 2 minus 2 log of 3. And I'm going to caution you, and I'm going to write this to where it's not so jumbled. So log of 2 minus 2 log of 3. So essentially what you have, and I'm going to move my work up here. For this next step, you have negative 2 log of 3 divided by log of 2 minus 2 log of 3. You must use parentheses to group that denominator all together. And again, you could do it piece by piece if you want, but just try not to round multiple times throughout a problem. Keep decimals in your calculator. All that's greater than x. So if I simplify that value to the nearest thousandth, you would get 1.4608 is greater than x, or x is less than 1.4608. So anytime you have variables on both sides of the equation, like we're going to get another example for number 35, it's just a little bit extra work. Number 33, log base 5 of 72 minus log base 5 of x equals 3 times the log base 5 of 2. This one is not following the same rules. My variables are not stuck in an exponent. My variables are stuck inside of logs. Now, technically, you have to remember is that logs are different representations of exponents. And the rules here that if they all have the same base, I have a log minus a log with the same base. And just like your exponent rules, when you're subtracting these, that means that we are dividing its components. So the log base 5 of 72 minus the log base 5 of x is the same thing as 72 over x. Okay, so the subtraction correlates to division of the inside terms. And that's going to equal the log 3 times the log base 5 of 2. So kind of like when you take the log of both sides over here, the exponents drop out front. Here we're going backwards. The exponent out front will rise up to the exponent of that inside term without the log. So this would be equal to 2 to the third power. So then we get 72 over x equals 2 cubed is 8. So 72 divided by what number is 8? Well, this is true if x is equal to 9. Number 34, I'm back to an example where I have an exponential term. My variable is a part of an exponent. So I want to go ahead and isolate that term first. I'll subtract 10. I get 3e to the 3x minus 7 equals 18. And it's still not isolated, so I need to go ahead further and divide both sides by 3. And I end up with e to the 3x minus 7 is equal to 6. Again, e for me triggers that I want to go ahead and take the natural log of both sides. And in doing so, this 3x minus 7 is going to fall out front. So that'll be 3x minus 7 times the natural log of e equals the natural log of 6. The natural log of e is equal to 1. So again, that term is omitted. And then I'm left with 3x minus 7 equals the natural log of 6. Well, then I can add 7 to both sides. So then I end up with, if I move my work, 3x equals the natural log of 6 plus 7 is approximately 8.7918. And then if I go ahead and divide both sides by 3 to the nearest thousandth, again, keep that long number in your calculator. Just hit divided by 3. You should get that x is approximately 2.9306. Number 35, I have exponential terms here, but again, they're already isolated, and there are 2 of them. There's one on either side. So there's not e, so I can go ahead and take the log of both sides. And in doing so, those exponents are going to drop out front. So that first exponent will be 3x times the log of 4 equals, in parentheses, you got to keep x plus 1 together, times the log of 6. And then again, I have x's on both sides. So it would be beneficial if on the right side I distributed this log of 6 to both of these terms. So I have 3x times the log of 4 equals x times the log of 6 plus 1 times the log of 6. It's just log of 6. And then I want to get my x's, the log terms with x's, to the same side of the equation. So if I move this x log of 6 term, and I subtract that from both sides, then the left side becomes 3x times the log of 4 minus x times the log of 6 equals the log of 6. And now that I have both of my terms with the x together, I can factor out that x to get 3 times the log of 4 minus the log of 6 equals the log of 6. And then if I want to isolate x, I'm going to divide both sides by 3 times the log of 4 minus the log of 6. And again, you've got to be so careful in your calculator. You do log of 6 divided by, open a set of parentheses to do 3 times the log of 4 minus the log of 6. And then x is isolated once you do that, so that's your final calculation. And you should get that x is approximately 0.7569. And again, you can go back and plug this answer into the beginning and make sure that it makes a true statement. Numbers 36 and 37 go back to our logarithm properties. So again, we don't have any exponents where we need to isolate these terms, we're going backwards. I'm now giving you logs, and you're using your properties to put them back together. So earlier, we said anytime you have a log minus a log, that meant you divide the components. Well, if you have a log plus a log, then that means that you're going to multiply the components. Again, they all have the same base. So this means x times x minus 2 is equal to just log base 2 of 15. That would just be 15. And then I just want to solve for x. So you can go ahead and distribute this x. So to be x squared minus 2x, move that 15 over to the other side. Since I have a squared term, that implies that I'm probably going to factor. Two numbers that multiply to be negative 15 and add to be negative 2 would be x minus 5 and x plus 3, which means our answer would be x equals 5 and x equals negative 3. However, you're not allowed to take the log of a negative number. So when you do these problems, if you end up with a negative answer, you need to throw it out and only accept the positive. Similar scenario with number 37. I've got all of my logs have the same base of 5, and I've got the log of a number plus the log of another number. When I add them, that means I am multiplying the components. So 10 plus x times 3 is equal to 93. So then distribute this 3, which will be 30 plus 3x equals 93. And then I want to solve for x. So I'm going to subtract 30 from both sides. So I get 3x is equal to 63. Divide both sides by 3, end up with x is equal to 21. Number 38, Maria invests $8,674 in a retirement account with a fixed annual interest rate of 9% compounded continuously. That triggers which formula you should use. Continuous compounding uses the formula A equals P times E to the RT power. How long will it take for the account balance to reach $27,947.56? So if I substitute in what I know, my final balance is $27,947.56 equals P is our principal, our initial investments, which her initial investment was $8,674, times E to the RT power, rate 9% is 0.09. And then T is what we're solving for when it says how long will it take. That's our unknown. So now this question becomes just like these solving questions up top. My exponent, my exponential term, and my unknown is a part of an exponent. So I want to isolate that term first. To do so, I'm going to divide both sides by 8,674. So then I end up with 3.222 is equal to E to the 0.09 t power. And again, to get that exponent down, I need to take the log or the natural log of both sides. Since I'm using E, I recommend you taking the natural log of both sides, because then that exponent value will drop down in front of the natural log. So then I have the natural log of 3.222 equals, my exponent drops in front. So it'll be 0.09 t times the natural log of E. Well, again, anytime you see the natural log of E, and that's the reason we use natural log, is that it's equal to 1. So then if I do that to isolate t, it's just being multiplied by 0.09, so I can divide both sides by 0.09. So you'll take the natural log of 3.222, or hopefully you have that long decimal stored in your calculator. Divide that by 0.09, and it'll be pretty obvious, just like it will be on your test. These particular questions should, as long as you don't round too many times, be obvious that you're going to go ahead and round to the nearest whole number for time. in this case should be about 13 years in order for your profit to reach that $27,947 mark.